you downstairs. We are so very glad that you're all here. We have a stacked lineup for you this evening. Starting off with Susan Chang, a principal data scientist at Elastic, Nyah Macklin, senior developer advocate at Neo4j, followed by Akriti Keswani, developer relations engineer right here at Airbyte, and Daniel Dai, data architect at Roku, Junping Du, or JP, CEO of Datastrato. So one very full evening of a lot of fantastic data engineering talks, data for AI topics. Who's excited? Are you guys excited? I'm excited. Come on, right? What is it? It's a Tuesday. It's Taco Tuesday, and we're doing pizza. We're already got one foul on the play. I think we're going to make it, though. So moving forward, we have a special thank you tonight, of course, to Elastic, Neo4j, Datastrato, and of course, Airbyte, because we are in their offices right now. We're so grateful for the space to not only bring these fantastic speakers to you, but to bring community together, because that's what Data for AI is actually all about. I am your host. My name is Jessica. I'm the founder of a couple different things in the world. I've been a tech product executive before. I'm recovering, thank you. And I'm also the Data for AI host. So if you have any questions about any of that stuff, you can find me on LinkedIn. This thing right here will actually shoot you over there. I'm actually a very difficult person to find because there's not that many Jessicas in the world, but there are actually at the same time a lot of Jessicas in the world. So the little link there might be helpful. Okay, again, I'm accompanied by myself, Lisa, and Lindsay. We do this thing, we meet weekly. We try and make sure that we bring you the best speakers in the land on data, in AI, and we work our butts off to make that true. Our speakers tonight, we're going to kick it off with Susan. Susan, who here knows who Susan is? I think a few of you might actually know who this marvelous woman is. She's a principal data scientist at Elastic with previous ML experience in fintech, telecommunications, social platforms, and is an internationally renowned speaker with talks at 6 PyCons worldwide, keynotes at Data Day Texas, PyCon DE, and PyData Berlin, and she's a superstar of O'Reilly's AI Superstream, with a best-selling book, Machine Learning Interviews. Go check it out. It's available on Amazon, among other places. And without further ado, I will introduce Miss Susan. Thank you.
All right, thanks so much. Very glad to be here every time I'm in town. So I'm actually from Toronto in Canada. So every time I fly down here, there's a lot of things to do. I was actually a track host at a conference down the block called QCon. So it's a conference that's been running for 15 years or so. And I was part of curating the machine learning and AI track there, but my hosting duties are done, so now I'm here. Yeah, so back to backs, but my friend Lisa invited me, so I couldn't say no. All right, so today I'm going to be talking about word embeddings and information retrieval techniques. For some of you, this is going to be, some of you will know some of this, some of you might know all of this, and some of you might have known part of this, but I'm just trying to merge some different fields together, and hopefully it'll be helpful. So as mentioned, I work at Elastic, Elasticsearch. We have a headquarters at 88 Kearney. I don't know if I'm saying that right, and Market. I've spoken at PyCon, and author of this O'Reilly book. And I'm going to be doing a keynote at PyLadies Con in December, which is a virtual and free Python conference. So raise your hand if you use Elasticsearch, or Neo4j, or Airbyte, Datastrato, Roku products. Okay, quite a few of us. Wanted to add everyone. So today I'm going to be talking about a few things. I'm going to be talking about information retrieval techniques, one of the most classic, simple ones. And that's called BM25. I'm going to be talking about word embeddings, and then last I'm going to talk about kind of a combination of both of them. So first of all, BM25. So a lot of us probably work at companies who have a search function just like this example. Here we have a product website, and then we have a search function where you might be searching for plumbing irrigation systems. And then by doing this search, you will be expecting to find relevant products, and you can, extrapolate with any content or music site or whatnot. So bag of words representations have been around for many decades. In machine learning, I guess a few years ago, it was like kind of hot to use TF-IDF, which is term frequency inverse document frequency. I don't have time to go through all of this, but in short, we have, let's say we have a few articles or documents. Here we have Shakespeare's plays. The idea is that for a word, if it's possible that like a word shows up rarely in all these plays, which is Romeo. So in all of the plays, Romeo will only show up in Romeo and Juliet. So the actual occurrence is low, but the importance to that passage or that document will be high. So Romeo appears not frequently, but the importance is high to identify the word Romeo will show up in Romeo and Juliet. So you can see that for words that appear in many plays, like good and sweet, the appearance is going to be counted really high, but the relevance, the IDF, is going to be just basically not important at all. So even if you know that the passage has the word good or the word sweet, it doesn't really help you find the relevant information at all. So that's one of the, just like the basic techniques, and BM25 is one classic ranking function in information retrieval. It's also a bag of words retrieval function. So the intuition is the same, which is the occurrence of words as well as the importance of a word to a document, a passage, or anything like that. So these are trying to translate a lot of text into like this numerical representation of importance. So that's one thing we'll be keeping in mind, which is we have a lot of text. We want to search it. To make it faster to search and to make it kind of mathematically possible, we'll turn these words into more of a numerical representation. So these are not embeddings, but they're also ways of representing text as vectors. BM25, keeping track of time here. So BM25, this is what happens in Elasticsearch, like the basic stuff that happens in Elasticsearch or other kind of data stores or retrieval methods that use BM25 or something similar, which is maybe you have a few documents, you will have some pre-processing pipeline which will remove, let's say, stop words, or you will keep track of stop words, like the words that are not super important, like a, and, around, every. And then you'll create this crucial thing, which is called the inverted index, which is, it'll be the words, the unique important words in all of these documents. So like, for example, the Wikipedia corpus. It'll have a list of all the words, which is basically almost all the words in the English language. And it'll say document A has the word best, document B has the word best, or some sort of documents with the word related to, let's say, United States history or something as the word like Constitution or so on and so forth. So the inverted index, in short, is the vocabulary by what passages or documents have this word. And how this works for information retrieval is that we might type something into the search bar, like blue sky. Let's say you want to query something in Wikipedia. So you're going to type your query word. It'll look at the inverted index, and then it'll find, let's say, the words blue and sky. And this is where the general like algorithm happens, which is it'll find the documents that have the word blue and the documents that have the word sky. And then there's some more tuning and whatnot to rank them, because there might be multiple documents which have the word blue or sky. So sometimes when you combine them, I don't know if you can see this, but documents that have both words will be ranked higher. So it's what we call like a lexical way, which is more like words matching based way of searching and retrieving relevant information. So it's not machine learning. It's just an algorithm, and it's still a strong baseline to compare machine learning algorithms against, because if you're using a machine learning method and you can't even beat this, right, it means that something is wrong. So there's more ways to tune BM25, and there are some blogs here, but I'm just going through the main intuition. So BM25 and other methods like this are built into Elasticsearch and other similar technologies, and there are some pros and cons here. They're not machine learning based. That's not a pro or a con, it's just a fact. They don't really capture semantics. I'll go into that more. It's a keyword-based, lexical-based, and it uses inverted index. Okay, next, vector embeddings. So this is, what we've been hearing a lot about these days with Gen AI and stuff like that, but embedding models have existed for a very, very long time. Embedding models, in short, are just like large models which will turn text into more like a vector numerical representation, and these are called many names: vector embeddings, or embeddings, word embeddings. Like they're all this. So in short, the embedding is a lower dimensional representation of high dimensional information. And a good embedding model will capture like the vectors, they look like gibberish, but if the embedding model is performing as it should be, then the gibberish is going to have meaning, like it's going to represent different concepts as numbers. So in other words, text is now turned into numbers, which is actually similar, very, very low-level intuition as the kind of bag of words methods that we just mentioned before. To make things easier to rank, to make things easier to search, we're trying to represent words, images, and other types of media as numbers because we like that. And machine learning models are happy. They love working with numbers. Here we have just some more intuition here. We might, for people who are working in RAG, like retrieval augmented generation with large language models, you might be familiar with word embeddings. They're different. The embedding models are not the same models as the large language models. Like GPT models are not the same as the embedding models that OpenAI provides. They're totally different models. Search engines have also been using this for maybe almost a decade, embedding-based search. So yeah, like we have some other of these. So where does this come in? I mentioned the keyword-based search earlier, and if you want to build a search which, not just does this keyword match, because if you don't search the exact correct things, then you might not find the right items. But rather you want to maybe have a more ambiguous or chat or natural type search, then you'll say, you want a search bar that could say, what materials and tools do I need to build an irrigation system, right? And you want this to retrieve the correct results. So there's some downsides here. Okay, keep me honest on the time. If I'm like running out of time, just let me know. But these can't account for semantics. If you're just matching, then the meaning will be, not captured. That's what it means. Semantics means meaning. So it doesn't capture the meaning. But nowadays with language models, and I guess we want to capture similar meaning. So it's kind of like using synonyms or whatnot, but capturing similar meanings is more than just using a synonym list. It's more about the similar meanings across maybe an entire sentence or a phrase to match to a different sentence, which could consist of many words. So The machine learning-based vectors or vector embeddings aim to capture the meaning, not just the keyword-based. And they can be further fine-tuned to specific tasks and domains. Okay, quick crash course on what are vectors and vector similarities. I showed the vector representation of the text, which is just like a long, vector of numbers. So, you can project that into a very high dimensional space. So like a vector of like the word cat could be like this in a very high dimensional space, and then like the word dog would be like this. But for simplicity, mapping it onto two-dimensional space. Why do we call this vector similarity or semantic search, which is the word, let's say dog turned into a vector, or I don't know, looking for a cute pet would be in like this in the vector space. And then maybe an article about dogs or adopting a dog would be in this kind of similar location in the multi-dimensional vector space. So that's how we use vectors to retrieve similar documents or items. Okay, skip. Okay, so we have these vector, so this kind of vector is called dense vectors, but as I mentioned, you want to find the same similar distance, right? So we are using like the distance functions as defined here to calculate the distance, right? If the distance between A and B is far away, then they're far. If the distance between A and C are close, then they're close. But first you have to calculate them. Unfortunately, it's really expensive to do the pairwise computation of all of these dots between an incoming query, incoming search, and all of the things that exist, right? So super expensive. In summary, we use an algorithm called HNSW, Hierarchical Navigable Small Worlds. It's a implementation of an approximate method to find the distance. So let's see. Okay, one more intuition I'll give you is that like using machine learning methods, it can differentiate something that keyword-based search cannot, which is, for example, raise the bar and going to the bar mean different things. But keyword search will think they're the same thing. So that's like another benefit we have. Okay, question here, because I just dumped a lot of information, but who's been working with vector embeddings recently? Okay, good amount. Maybe like a third or almost a half. So here's like one open source vector embedding model. I'm not going to go into the details, but this is how it might work in a semantic search. Semantic search is that like, if you type a more like conversational question or something like that into a search bar, like it'll use the meaning to retrieve things. So that's called semantic search. So this is how it would look like. We would have the embedding model. It would output the dense vector, which is that vector that looks like a lot of numbers, and then you will use an approximate search to find the relevant documents or the relevant products in this case. So this is a summary of dense vectors, which is they can capture semantics. You can fine tune it because it's a machine learning model. You can provide it more information. Let's say your firm is trying to use a open source embedding model. You're trying to fine tune it for understanding legal documents or medical documents. You can provide it with more data, and then it can learn more from that. And computation, unfortunately, is slower, even with the approximate method. So that's one downside which we really want to solve. So let's go into the combination of both of these. 45. Okay, it's been 20 minutes. Okay, let me speed this up. Okay, I'm just trying to keep on time, generally. Okay, so. As I mentioned, the example, we want to go from the keyword search to more like a conversational or semantic search, where even if you don't match the exact same words, it would find the same meaning. So this technique is called text expansion in the industry, which is this other type of embedding model called sparse embedding. So what you saw earlier, this is called like a dense vector embedding because almost every kind of item in the array is populated. But a lot of them are going to be zeros in a sparse embedding model. So here we have an example of what it means to have a semantic search, again, but it's a kind of like even if you don't search in your, type in your query orangutans, or you're typing large monkeys, right? A keyword search would not pick up that this could be a similar concept to orangutans, great apes, or gorillas. Jungles could be related to lands and rainforests, but keyword search, again, wouldn't pick this up. So we want something that does this. And nowadays, we call this query expansion, where even if the user has this query, in the back, we're doing like expansion to expand the items that the user can pick up, depending on the semantics, depending on the meaning. So this is one model that Naver Labs Europe developed, which is called Splayed. And Elastic also has another one that works similarly, which is basically the same way of working, called Elser. But the intuition is this. It's more the combination of a BM25-like implementation and the dense vectors. So the vector would instead look like the length would be the, let's say, the English vocabulary or language of your choice. So you might be thinking that's a lot of words. Like, yes, the length of the vector will be very, very long. And most of the items will be 0. So in this example, let's say someone is searching for Wikipedia articles about international organized crime. So the representation of this query would be something like, the Splayed here. So Splayed is the sparse embedding model, and it would say that this query is related to the word organized, which, there's an exact match. It would have a higher score, 1.85. And it would also be highly relevant to the word crime, which also has a higher score. But using the machine learning methods, you will also pick up on similar words like criminal or global. But this is the representation from BM25, which would just be 0 unless you have an exact match, which is organized, international organized crime. Everything else is 0. So for the machine learning methods, they would still be, it would pick up relevant words and concepts, but it's not going to be relevant for everything. So we're still going to have a lot of zeros all around. So let's see. Yeah, so one thing similar to BM25 that I mentioned earlier is now you can construct an inverted index from this because you have the length of the entire vocabulary as well as like the relevant scores for all of them. So so here you would substitute this into one of those, let's say, RAG architectures or semantic search architectures that I mentioned before with the dense vectors, but you're just substituting in the sparse vector. So everything looks generally the same. Just the difference is that instead of using the approximate nearest neighbor search, which is still expensive, you're using inverted index. So this is much faster. I don't know if that was convincing enough, but it's much faster to just like retrieve it from an inverted index, like as fast as using a non-machine learning method, which is, and you don't have to do a pairwise computation for every single thing. And you might be thinking, oh, for every concept, like you have to store the entire vector. Isn't that expensive? Like we actually don't store all the zeros in Elasticsearch. We just do like a mapping. So we don't actually have to store all of that, which is even better. So in Elastic, we have this model called Elser, which works the same way. And these are the benefits of the model, which are captures the semantics. You don't need to fine-tune it for a general English language understanding. and you find it through inverted index computation is passed. And you can also interpret it at the word level, which is you can immediately understand that, oh, the score for, let's say, criminal is high, right? So you can know that, oh, this is why the search returned this result. But if you are using a dense vector search, then you wouldn't really necessarily understand like why this search returned this result. So that's like the main comparison here. And okay, let's see just some going over. So yeah, happy building. You can use these methods in combination. So some techniques nowadays are just, let's say, hybrid search and so on, where you can merge, you can use like just BM25 to, let's say, do quality checking, or just like to retrieve an initial set of documents and then use machine learning to re-rank them, and so on and so forth. And this technique is also the foundation of RAG as well, which you might be hearing about. And then you can also use embeddings for multilingual or multimodal use cases. So that's the intuition behind it, as well as some of the trade-offs. So yeah, thank you. Okay, so the question was, if you're already using RAG, how would you use sparse vector? Yes, so you can do a kind of quick substitution or just like a separate call. Like it'll be in the same pipeline, because like in this diagram, like originally you would have a dense vector embedding, which you probably have in RAG. So you could just instead use that, you call it the sparse model instead of the dense model, and you would store them in the same place. You can store them in a vector database like Elastic, which supports vector, and other vector databases, of course, whatever you're using. But they can be stored in the same places. It's just that, Elastic, we do have some optimizations for that, but you can actually store this like wherever you have your embeddings. Yeah, so in short, you can, put it in the same place.
Any other questions?
Thank you so much, Susan. Can I get a round of applause? Before we move on to our next speaker, I just
All right, thank you. So we'll double that note, just to make sure everybody in the back heard that too. Clean up after yourselves, please. Okay, next up we have Nyah Macklin from Neo4j. Thank you. I'm so excited to have Nyah speak with us today. She's a developer relations leader with years of experience leading both technical and cross-functional teams to provide value for both internal and external stakeholders, from the individual contributor engineering level to the C-suite. She's a seasoned keynote speaker and motivational leader. Let's get some motivation tonight from Nyah. Welcome to the stage.
Hey everyone. Thank you. Hey everyone, how y'all doing today? Doing all right? Okay. It is getting way too cold out here, y'all. I don't know. I'm from the South, and I'm not used to this cold weather, so I don't know how y'all do it. This is ridiculous. All right. It's freezing. All right, let me see. Okay. Oh, great. Thank y'all for bearing with me. And how many of y'all have been to the Data for AI meetups before? Couple folk? Okay, a couple folk. Most people, this is new. All right, very, very cool. Have y'all heard about the term GraphRAG before? Okay, a couple head nods, wonderful. Okay, a couple in the back as well. And who is a GraphRAG expert in this room? Okay, I see a couple. We are doing this presentation together, my friend. This is an us presentation now. Okay, so let's see. Let me get this all up and running for you all. Boom. And then let me try to move this over. Boom, boom, boom. Great. Lovely. All right. Sweet. Sweet. All right. Cool. Okay. All right, so just to introduce who I am, everyone. So my name is Nyah Macklin. I am a senior developer advocate at this incredible company called Neo4j. Has anyone heard of Neo4j before? Worked with it? Oh, yes! That is incredible. So excited. And for those who don't know about Neo4j, we are a graph database and analytics platform. We're trying to show lots of people not only about what the power of graph databases are, but also, right, the power of GraphRAG and using RAG and retrieval augmented generation. So my incredible colleague right before me, they had just gone through what vector search is and RAG and broke that down for you all. And I'm going to do just a little bit of an introduction on like the evolution of web search, something that they had just touched on as well, and then getting into the power of GraphRAG and possibilities as to why it might be helpful to use GraphRAG technology when you're building your either both Gen AI applications or just artificial intelligence applications as well. Okay, so any questions before we get into it? Okay, lovely. Let's get started. Oh, and I realize I'm in the way a little bit, so some of you might not be able to see the whole presentation, so I'm going to slide this over and get out the way so that we can do that. Lovely. All right, let's go. Perfect. Okay, so most of us today, right, when you hear, when you're going to search something up, what are the biggest things that you're using when you're doing a search, any kind of search? Google, yep. Anything else? Say it again, ChatGPT. Perplexity, excellent, excellent. That's right. So many of us are using all of these various search engines. So before, something like Google, right? Google handled a majority of the web search. So, sorry, before Google, a number of those web searches were handled by a number of different organizations and companies. So right now, we're using things like Google, right? Brave, for example, for those who care about security, myself included, and DuckDuckGo as well, just the initials. And those are a few of the big players. However, right, does anyone remember some of these huge, huge players way back in the day, right? Back in the 90s. So, say it again. Oh, wasn't born. Oh, no. It's okay. That's okay. We do not judge you. This is a loving and welcoming environment where we're going to learn together. So that's okay if you weren't born yet. Okay, well, for those who were born and understand, Ask Jeeves was one of my favorite search engines back in the day. But Yahoo, AOL, these kids, they don't know, y'all. They don't know. Lycos, for example, as well. These are several different web search companies who had similar underlying technologies, right? Powering their search and some version of pretty much some version of a keyword-based search. And my colleague had mentioned that as well. So keyword-based searches and the like. And everything was all in fine, right? We had lots of different competition when it came to search. And most people, everything was fine until most people started, coming onto the internet. There's this big thing called the internet, and people are like, hey, I want to get on there, and I want to create myself a little web page, okay? So everything with keyword search was perfectly fine until this massive boom of various web pages, and that means more and more people are starting to use it. So what happens when more web pages start to overpopulate keyword search, right? You're having more and more web pages, and it starts to overpopulate keyword search. Users become inundated with the results, right? So we're starting to see the, initially, right, we saw keyword search, full text search, and we had a number of different players in the game. And, I don't know about you all, but I personally do not have time to parse through 827 million different results if I'm trying to learn about graph technology, right? Don't have the time, don't have the effort, I'm not going to do it. So if I'm trying to learn about a particular concept, right, there has to be a better way. And so in the ripe year of 2000, when some of y'all weren't even born yet, a very large tech company helped solve this. Do we have any guesses as to what tech company that was? Not the expert. Any guesses? Which tech company was that? Google. Exactly. It was Google, right? So Google then came through, and it was a breakthrough in web search. That's why Google's the main player now. So it was the head honcho themselves, Google. In 2000, Google launched a press release, and you can search it up right now and read the original press release, and it was titled, Google launches the world's largest search engine ever, right? The world's largest search engine, where they have indexed 1 billion URLs. Hard to believe that there were 1 billion URLs in the year 2000. But they did not stop there. They dove into this pivotal technology where they were using their particular algorithm to place the most relevant information at the top of those results. Does anyone know what that was? I'm sure y'all knew it. That's right. It's PageRank, y'all. So for those people who haven't heard of this incredible sourcing algorithm called PageRank, it is very, very pivotal when it comes to graph technology, right? So PageRank, huge. And feel free to look up this article itself. So PageRank, what some people don't know is that PageRank is actually a graph algorithm, right? So it's a variation. So for those who might not be, who might not know about graph theory, it's a variation of this concept called eigenvector centrality, right? So, and eigenvector centralities, I know probably my graph expert knows what that is, but has anyone heard of that before? No. Some. Okay, a couple folk. So it's pretty much a measure of the influence of a particular node, and a node we can just simply describe as a piece of data, for example. So it is the measure of the influence of a particular node that particular node has on a network, right? So on an entire network. And so here we see, if you look up PageRank, especially on Wikipedia, support Wikipedia, you'll find that PageRank is an algorithm used by Google Search to rank web pages in their search engine results. And like we had mentioned, graph theory. All right? So Google's use of PageRank, right? Their use of this specific graph technology helped propel them to become one of the most powerful search engines for a long time, right? So from 2000 to 2012, Google, because of PageRank, had propelled themselves to become a leader within web search, right? And then, okay, Google is never stopping. So, and then in 2012, they also released this paper introducing the knowledge graph, things, not strings. This was in 2012, introduced by their SVP of engineering, Amit Sanghal. Feel free to take a picture if you want to learn more and read more about this particular paper. But they had introduced this concept of a knowledge graph. And for those who don't know what a knowledge graph is or have never heard of a knowledge graph before, a knowledge graph is an organized representation of real-world entities, right? And their relationships. So me and my new friend, who I had mentioned in the back, right, my graph theory expert, I'm a node, they are a node, and we now have a relationship, right? So we now have a relationship. So a knowledge graph is an organization of that, or an organized representation, right, of the relationships and the nodes that exist. We can now have a relationship, we're new friends, right? We can have relationships, we're new friends. To the one who wasn't born yet, right? We have a relationship as well. We are new friends, right? So a knowledge graph is a representation of data, right? And an organized representation of real-world entities and their relationships. So, when you do a Google search, as most people can do now, right? When you do a Google search for information, it uses connections between the entities or the nodes, right? It uses connections between us, the relationships that I was mentioning before, to surface the most relevant results in context, right? So when you see this page, right, so example, you look up this, you'll often see this little side page for a particular thing, right? This side page, what Google calls, is the knowledge panel. You remember knowledge graphs? Very similar concept, right? So this knowledge panel. And all of the data, right, that Google is showing us, even today, right, is the knowledge graph that is made up of nodes, which are people, places, things, objects, institutions, and the relationships of that data. So previously, when I had just showed you all this particular knowledge center that they have, this is summing up different information, relevant information that it's bringing from all these different URLs that it thinks is the most relevant for you as the end user to be able to understand. So this is all knowledge graph work, which is very, very cool. So we're seeing here, for example, all of the nodes, the relationships that are existing, the information that's coming together to put this piece of information in front of you as the user. This is the knowledge graph, and it is summing up all of that information, bringing up what's most relevant and presenting it to the user. So this, right, this era, the knowledge graph era, is what allowed Google to continue to climb in dominance as the world's leading search engine, right? The knowledge graph era, as we can see here. And that's all the way up until 2024. But yet again, they did not stop there. This summer, did anyone go to Google I/O? Okay, I saw a few people. Not many people were able to make it. Tickets are expensive. But for those of you who were able to attend, this summer at Google I/O, Google had just released their newest development. Of course, right, with the popularity of generative AI, right, so many companies are trying to figure out how are we going to utilize LLMs in order to create better products that suit our users. And so Google, at Google I/O, had developed and began using LLMs and GraphRAG to then usher them into the future, right? So this concept of GraphRAG is now being talked about. And I know a number of you have heard of the term RAG, right? And then we're going to talk about what GraphRAG is. What's the difference between them as well? So we're seeing Google being propelled into the newest era, which is the GraphRAG era. Yeah, feel free to take any pictures that you like. So, right, we can't even have this conversation if we don't come up with a common knowledge around what is GraphRAG, right? So we went through the evolution and the history and the breakdown of knowledge graphs right before this and how they came to exist, right? And now we want to get into using GraphRAG for your own RAG-based applications. So what is GraphRAG, other than my experts? And anyone give me their own version or their own summary of what GraphRAG is? Yeah. Absolutely, absolutely. So that specific answer, I want to make sure that folk who are not into this field, did everyone understand that answer as well? And if not, is there someone else who has a different definition or their own version of a definition? Feel free, do not be afraid. That's okay. That's all right. We're learning together. We're learning together. So GraphRAG, right? When we think about GraphRAG, GraphRAG is RAG, so we've heard about this term, RAG, Retrieval Augmented Generation, but GraphRAG is RAG where the retrieval path, the R path, includes a knowledge graph, right? It includes a knowledge graph. So that's the simplest definition that I've come up with. And so I want to get into the architecture of how that even works, right? So the GraphRAG architecture. So let's say that you are a software engineer, right? And you got a new role. This is just an example to help illustrate the power and the use of GraphRAG. So let's say that you're a software engineer and you got a new role at insert famous tech company here, right? And you have to go read the docs. Okay, now, so many different engineers know that the pinnacle, right? The thing that we cannot stand doing the most is having to go read some documentation, okay? Please don't make me read documentation. And the thing is, right, documentation is incredible, right? I personally, as a software engineer, I love reading documentation. However, so many engineers, they will spend 10 hours trying to debug a particular issue before they just read 2 sentences in the docs. So in this particular example, to illustrate GraphRAG, you're an engineer and you're trying to build an application that makes it easier for your fellow engineers on your team to get answers from the documentation. So we're going to do this by using the power of LLMs because we're in the age of generative AI. And we're going to use RAG to do this as well. So you take all this data, right? You're going to take all your data and you're going to take it as a text documents here, right? And you're going to add all that text as properties onto particular nodes. We had mentioned that we are individual nodes. We're going to add the text from the documentation as a property on the relationship between these nodes. And this is all, I'm using language jargon, I would say. I'm using jargon that's very heavy. So if, for example, this is like going over your head, let's talk afterwards as well. But I just wanted to be specific about what I'm talking about. So you're going to take all the data, you're building this application, you're going to take all the data as text documents, you're adding that text onto the properties of these nodes, and you have one node per piece of documentation. So every node that you create is a piece of documentation, okay? Remember, we're creating an application that's going to synthesize all of that documentation. So right now we're creating nodes that represents each piece of documentation, and now we're going to create relationships between those nodes, okay? So we're going to note that these are related and they're significant in some way. So this piece of, you can also, when I was talking about that certain nodes are related, for example, you can say that you can say that this particular node is more important than the others, in the simplest terms. So then, right, the end user is going to say, okay, other engineers who are using your app, they have a particular question, right? this question can be anything about the documentation. For example, what are some dependencies that exist if I start building this feature, this random feature, right? On our monolith code base at that. So your user has a question. What are the dependencies that exist if I start building X feature on our monolith database? So what we would do as the developer of this particular application, we're going to vectorize that actual search that they had just put in. We're going to get vector embeddings from that search, just like my colleague had mentioned before and broke down vector embeddings, right? We're going to get vector embeddings from that search. And then we are going to, and then this is where GraphRAG piece comes in as well. We're going to get the core articles back where you're linking to the nodes, if you remember the text itself, from that documentation of the particular nodes, and then using graphs to traverse it all from there. So let's make sure that the animation is coming up again. So your user asks the question, whatever question that is. You're then going to vectorize that search, right? We're going to vectorize that search and get a vector embedding back. And then we're going to use that search to get core documents, the core documentation, right, that we had put in. And that's where the GraphRAG piece comes in, all right? And knowledge graphs as well. So you're going to get those core articles back, which are linked from the nodes that we were talking about. And then you're going to use the graph to traverse the nodes and retrieve context around those particular nodes as well, right? So you don't even have to stop there. You can use the context from vector embeddings, et cetera. But that is, we're going to grab the documentation from there. And then, right, you're going to then pass that along to the LLM, right? We're getting the documentation and the context. We're going to grab whatever summary that is, and we're going to pass it back to the user. Passing it back. And we're going to tell them what the particular answer is. Yeah, feel free to take a picture of this, of the architecture diagram. And you're going to, like I said, make sure that that is all put back. So user asks the question, get the vector embeddings, make sure that you are getting the knowledge is all, the data is all represented in a knowledge graph. That is one of the benefits of using a knowledge graph, is that it allows for faster, and we'll get into the specific benefits as well. But then you're going to grab that information, put it into the LLM, and then grab the summary from that and present that to the user. So all in all, and to summarize, because that was a lot, right? To summarize, all in all, the core pattern begins with, one, doing a vector search to find an initial set of nodes, right? Then traversing the graph around those nodes to get more added context. That's the benefit, getting that added context from those nodes. Not just grabbing the direct information, but also the context around it. And optionally, if we want to be Google, or if you want to create a company that's like Google, optionally, you can then rank those results using that particular graph and pass the top K, that's a technical term, documents to the LLM, right? So you can rank that information and then pass the top to the LLM and then have the LLM then pass that to the user. So in general, that is the GraphRAG retrieval pattern here. And there are a number of different benefits as well to using this specific pattern. So one of the benefits of using GraphRAG is, number one, higher accuracy. And of course, this is just one example of many different examples of the impacts of using graph technology. But specifically in this particular one, right? One of the largest benefits, what we had mentioned, is that accuracy, right? The quality of the answer that we're getting back from the LLM. So one of this specific example is from an engineer at data.world, right? And they were pulling 43 different questions, right? And they had found that from that, even that pretty small sample size, the average response quality was 3 times higher on average, right? When they use a knowledge graph versus just using a general graph, when just using RAG technology, right? In addition to vector search. So this is in addition to vector search, they saw that using GraphRAG on top of vector search allowed for a 3 times higher accuracy on average. And this is the paper down here as well for folk. You can either scan this and get access to all of this information here, but this paper is a benchmark to understand the role of knowledge graphs on large language model accuracy for question answering on enterprise SQL databases. Very, very informative paper, right? I love diving into this paper. And that was from November 2023, so pretty new. And then, yet again, like we had mentioned, this is just another example of the accuracy that you can create when you're using knowledge graphs. So LinkedIn specifically had published this paper, and it's kind of hard to see, so I just want to say it for you all. But it's titled Retrieval Augmented Generation with Knowledge Graphs for Customer Service Question Answering. And LinkedIn specifically, they saw a 75% to 77% increase in accuracy of those responses. Yet again, massive increase on those responses when they're using graph plus vector search, right? Graph on top of vector search. Very, very, very interesting findings. And another piece here for the higher accuracy, right? Microsoft in February, Microsoft this year, right? They had put out a number of different research papers about the increased quality of responses. And on top of that, GraphRAG allowed them to answer different kinds of questions that was not initially possible with just RAG alone. And they detail their findings in this paper here, GraphRAG, Unlocking LLM Discovery on Narrative Private Data. You can read more and research more about it. So for these organizations, GraphRAG and knowledge graphs helps them achieve higher accuracy in responses coming from the LLM. But higher accuracy is just one of the pros, right? Another pro as well is talking about easier development. As software engineers, a large part of most of our job is writing code and developing applications. And so and I must put a caveat, after it was easier to begin developing Gen AI applications after they had gotten over the initial learning hub of learning about knowledge graphs and how they worked. So the second impact that came about was the development process, like I had mentioned, after they had pushed through the initial learning phase. So once you learned about a knowledge graph and learned how to use a knowledge graph, then it was easier to create a GraphRAG application. So these are just some of the findings from, this was one engineer who had just started using Neo4j and Pinecone as well, and this was some of their findings. And so, on the interest of time, I'm not going to go through every little benefit as well for knowledge graph and GraphRAG, but I just wanted to show you all just an overview of some of the additional findings as well. A little bit of the easier development piece, and I'm sadly going to speed through this a little bit. But the benefits of and the differences of explicit versus implicit representation in data. And yeah, feel free to take pictures. Right, so the differences here, it's a lot. And also at the end of this, I can give you all a copy of my slides so you can learn more. But so lots and lots of easier development, lots and lots of understanding, right, the differences between trying to figure out what is going on here in this specific embedding versus seeing data represented in such a much easier way in a knowledge graph versus trying to actually represent it here, right? So transparent and very explicit representation of data versus a very implicit and opaque representation of data over here. Oh, sorry. And then the last piece was benefit being explainability and governance. So in particular, for example, we had a central IT and business decision makers, right, citing the ease of explainability and governance when it comes to using LLMs and generative AI applications, because you're able to get to the source of that information much easier than with a general LLM, which would pull in information from anywhere, right? Having to being able to actually direct the source of what that information was much higher rather than just using a regular LLM-based system. So small benefits: higher accuracy, easier development, and better explainability and governance. Of course, it's not perfect. We understand that working with LLMs is never going to, not never, I won't say never. Let me not say that. But is going to continue to increase in accuracy, et cetera, as we continue to develop, right? So getting started with GraphRAG. I had a demo, but we don't really have time for the demo. So we're just going to speed through this quickly. Yeah, I actually don't have time to do any of this, but yet again, let's have a conversation afterwards. And we can talk about how you can actually quickly get started with GraphRAG as well. And if you want to learn more, I always want to provide resources for folk who want to dive more into learning about LLMs and GraphRAG. You can learn more on Graph Academy. This is completely free online courses, interactive courses as well that we have for learning about graph technology, graph theory, LLMs, artificial intelligence, etc. And we have a number of different courses that you can build your own applications using graph technology here. And then we have a free giveaway that we always do for every in-person meetup. So we have this raffle to win a DJI Mini SE drone, which I have with me in the back. And you can feel free to come and look at it and play along with it. But we do this every 30 days. If you insert your information, we will send you an email and a text if you won. So we do the raffle every 30 days, so you have 12 chances a year to win this drone. Cool. Thank you. Thank you so much. Thank you, everyone.
Thank you so much. We have time for a couple of questions. Are there any questions? Yes, right here.
Hey, thanks for the presentation.
Of course.
Share a bit more about how the visualization works for the debugging stuff that you mentioned earlier. Like, I'm assuming you can't just represent everything in 3D for the graphs. Yeah?
So say more.
I want to know how the person used your system to debug the vectors easier.
Right, so it's because, and this would have been able to be shown in the demo. Actually, I might be able to get the demo working after the talk, so we can talk through it. Yeah, but it was the data visualization technique that we have. We have a particular product that's called Bloom. It's completely free as well, but it allowed them to understand where their data was in relation to other pieces of data, which then allowed them to debug easier when it came to that pretty much the debugging process. And so find me right after, and we can actually go through that. Yeah, thank you so much. Yes. Yep. So what's interesting is that you can actually you have the power to either with the system, it's called the LLM knowledge builder that we have, right? And so what you can do, LLM knowledge graph builder, right? And so what you can do is either leave it up to the LLM to decide what nodes are created within your system or database, or you can actually guide it a bit as well. So you can tell it what nodes to focus on when it comes to parsing out that information. Yeah, no problem.
So if my data is expiring, right? Let's say I want to run it on only on the most recent last 30 day data. If my data is anything more than 30 days, I want to delete it.
Okay. Is it equally effective if you're going to be deleting data? Then, well, I guess my question would be effective in what way? Yes, I would absolutely say so. And we can talk about it more as well. Yeah, come find me. Thank you. Thanks, everyone.
Thank you. Thank you. All right, folks. And next up, we have Airbyte's own. Just one moment. Let me get this thing plugged in here. Okay, next up. Akriti from Airbyte, right here in this office. She's pursued computer science in college, having various experiences. She's now working on building and advocating developer tools and aiming to expand more skills towards AI. Welcome. Thank you so much for sharing with us today. Give her a warm welcome. Is it only on that side?
Yeah, it's only on this side. It's okay.
Okay.
I'll just.
We can scoot this closer or move it to that side. I can help make sure. Okay, perfect. All right. All set?
Yep.
Should be on. Good to go.
Great. Hello, everybody. Can you hear me okay? All right. So we're here to talk about Airbyte's product and why data is so important. And without data, we can't have AI. So this is called From Silos to Seamless Data Flows. So first off, I'm sure you guys have heard of the issue of unstructured data. Data is not necessarily always clean and preparable for like actual AI RAG pipeline or any AI pipeline that you're building, right? So apparently unstructured data is projected to be 80% by 2025, which is insane. So data infrastructure usually, like whenever you're building anything with data, you need reliable data movement, and that's what we provide, especially for if you're trying to build a RAG pipeline in the future. Search capabilities like Elastic earlier presented, graph relationships like Neo4j, I think that all of them kind of go hand in hand, but what we do is we essentially, our mission is to take siloed tools and have them into integrated platforms or workflows that you can actually use to properly ingest data, move it, and have that data fabric layer, right? So I'm going to talk about like the AI challenge, which, as I mentioned earlier, without any data, you can't have AI. So what do I mean by that? I mean that whenever you're building any application, right, like you're ingesting large amounts of data, suppose you're ingesting it from Google Drive and you're trying to put it somewhere else and you're trying to build a pipeline on top of that and use RAG to augment your responses, your query responses. So in any case, you always need data sources. So there's different types of data. I mentioned earlier, there's unstructured data, there's structured data, there's transactional databases if you're dealing with financial records, e-commerce data, there's business apps, there's custom apps, and all this data is sort of like being locked away and we don't really have access to properly like in a tabular format, like in a very structured format. So the reason I'm showing you this right now is because I'm trying to identify where Airbyte fills in that gap. And eventually you want this data to go into like a warehouse so you can have multiple databases or vector stores so you can perform some kind of calculation or operation on it, as you mentioned earlier, through Neo4j Elastic, and how this all leads into vector DBs like VV8, Pinecone. So I'm gonna show how Airbyte kind of fits into the puzzle. So Airbyte fits into the puzzle because we have a bunch of different techniques, right? Like we have orchestration, processing. We have a marketplace where people contribute these connectors, these sources, And we have connectors, the actual connections themselves, connecting data from a source to a destination. And we also have transformation. How do we do this? We have a lot of techniques to like execute all of this. And part of it is like, for example, like pagination, or we have record selectors to filter through the data and actually like only identify specific things that we actually need.
I was wondering if we could full screen it so that we can take up the entire.
Oh yeah,
Let's see.
my bad. I think it's on a. Wait,
Yeah,
sorry.
I got this.
I don't know why it's doing that. I think it's
You're good. Perfect. That's
Sorry.
amazing. Yeah.
Okay.
Awesome.
Thanks for telling me.
Of course.
Yeah.
Yeah, no worries. You're doing incredible.
Okay. Sorry about that. I think it's, yeah.
Everybody can see this okay?
All right, so continuing on from how I guess Airbyte fits in to the whole movement layer. So I kind of like explaining the Airbyte kind of like the spectrum through a series of 3 steps. And the first, I guess, is no code, right? So these are 3 aspects of Airbyte, I guess. And what I'm trying to convey in this point is that even if you don't have a lot of programmatic experience, or you don't know how to like look at the API, as mentioned earlier, like programmers spend so much time looking at documentation, and it's really exhausting figuring out like what base URL or what endpoint you're hitting. We solve that problem by AI Assist, and right now it's in beta, but we've released this feature where you can actually scrape through like an API like documentation like properly, and you can have all the relevant tools that you need to enter into any requests. Suppose you're doing an HTTP request for a REST API, so you can use that. And then there's also a low-code aspect where, you can still know the concepts of like a GET request, a POST request, right? But you're entering the relevant information you need into Airbyte's platform, so you can connect any source you want to any destination. So that can be like Postgres, that can be BigQuery, whatever you're using, right? And pro code is the last aspect. We have this thing called Airbyte, and it's essentially like for, I guess, more seasoned programmers and for people that actually want to have more leverage over their connections and sending a source to a destination. So this is like the developer experience spectrum I just explained. And I'm gonna go right into the demo because I think the best way to learn is just to be practical about it. So yeah. So this is essentially like, I guess, how the Airbyte UI looks whenever you open it up in cloud. We also have a self-hosted enterprise. We also have OSS, which is open source. Self-hosted enterprise is more like, for example, if you want like role-based access control or like some tenancies, some like layer of that. And OSS, I guess, open source is like you can have your own deployments, you can have more leverage over what you're actually shipping. So this is the cloud-hosted version. The reason I'm showing you this is because it's also very like seamless to demo as well. But just know that there's way more out there that we offer. So I'm gonna start by creating any connection and showing you how like exactly we're able to send data from like Google Drive or Google Sheets to MotherDoc, which is an example of a DB, but it can be anything we want. So we would essentially click like have a new connection, and then we would select an existing source that I've already created, for example, if I have a custom source, or we can set up a new source. So in this case, I'm gonna do a new one, and I'm just gonna like put in some faker data that we already have to make life a little easier so we don't have to go through that. So I think it's right here. So now I have this like source that I'm using that Airbyte already sort of provides as a dummy testing tool. And we have a lot of documentation that's relevant to every source that we have. Because imagine if you're going to Google Drive's like API documentation page, right? There's a lot of like raw like information that you might not be able to immediately determine like what to use. So Airbyte does a pretty good job, I think, of abstracting away that complexity and just giving you straight like, okay, put in the source and connect this to this destination. So that's kind of what we're trying to do. So we essentially just set up the source. This is gonna take a while, so I think I'm just gonna show you the actual connection and how it looks. So apparently, so this is how we're setting it up. We're trying to connect the sample data faker to MotherDoc. So this is where I'm setting up the source, and then the destination would be the MotherDoc, which is the DB. So this is the destination layer, and there's an access token here, which is taken from your MotherDoc credentials itself. And you would establish a connection by basically connecting this pipeline to MotherDuck. So now that we have the source, it's defined, we can just straight up go to set up a new destination, and we can put in MotherDuck, which we have in the marketplace. And yeah, and then there's this access token, and you would essentially just set up this destination. I'm not going to set it up here because I need to put in my own credentials, which I have set up already. But yeah, that's how you would set up a destination. And ideally what would happen is that whenever you open up MotherDuck, you would be able to see all these streams that you defined. So you would see products like users, purchases, right? And those are the streams that we're actually like enabling in our actual connection. So I'm gonna go to the connection itself and show you how that looks. So here you have like all the enabled streams that we're having. And basically like this is giving you a lot of autonomy over like what you actually want to send, right, to the DB that you're using. And of course, this can be like Waviate, this can be a vector DB too. It doesn't just have to be a normal DB, but the idea is we're essentially trying to explain how a source can connect to a destination. And after this, I kind of want to show how the AI assist that I mentioned earlier works, because I think that's definitely a very important thing that we're trying to push out there. And as of now, I wanted to show off this example of Spotify's API, because I think everybody loves music, and why not just use the Spotify API, right? So, I'm going to start off by just trying to show like how to build that. So you would go into like sources, and you can set up a new source. And this would essentially just be like a custom source because we don't have that like in Airbyte connectors yet or marketplace. So you can also request a new connector if you really have that burning like idea, but you can also build your own source. So the way that we would do that is we would build a new custom connector, we'd start from scratch, and then we can use AI Assist to do that whole scraping API that I mentioned earlier, right? So you would enter any like public documentation URL. Here I'm just gonna enter like this, and then I'm gonna put it in here. I'm gonna call it like Spotify test data, and I'm basically gonna say create, and it's gonna do its work. And user stream would be essentially like what you're trying to gain out of this. So like in terms of like data. So like I'm trying to get like a series of tracks. So I'm gonna put songs. I'm gonna create that stream. So it's basically creating this stream right now. And the way that it should look on the UI is that we put in this base URL, and we're able to get all these like, I guess, details that we would initially have to like populate ourselves. But the idea is that this AI assistant is doing that hard work for us, right? So we have this token and refresh endpoint, and then we have these client credentials that we're entering through the Spotify API. So the way that it looks is like if you go into your Spotify API, and if you actually go into like an app that you made, I made this as a test, you can go into settings, and you can get your client secrets and client ID, right? So you would enter that relevant information here. And the way that you would set it up, for example, is imagine you have like a favorite artist, and you want to get all the songs, like a certain number of records from your favorite artist, right? So you would just enter that URL path, which corresponds to that endpoint. We're making a GET request, and we would basically have all these like records that we're outputting. So the way that it would work is you would set it up as you normally do like any request that you're doing, right? You would have like testing values, you'd have like client ID, secret, the token refresh endpoint, which is how, I guess, how often it refreshes, right? So, and then we can test it. So ideally, you should be able to get a certain number of like records that you're filtering on. So in this case, we're using a record filter. So we're actually like defining, okay, like I want the tracks for Death Cab for Cutie for this band, right? So, and I'm actually having these query parameters that are actually like giving me only that. So I'm getting 50 records, and I'm filtering through those 50 records, which is why I have 46 here. So essentially, this gives you like the power to sort of like, I guess, populate whatever you need to for the specific API that you're using. It kind of makes life easier, especially if you're dealing with very like, I guess, opaque APIs that like you kind of have to go through a lot to like just find basic information. So this makes life pretty easy. And then we also have like pagination, and we also have incremental syncs. Like we have ways of how data is updated and refreshed. So for example, I didn't show this in the connection, but I should probably go back and show this. But in here, so like we can also like, whenever we connected the data to MotherDuck, we can have like a scheduled job, right? Or we can have a cron job, we can manually do it. So there's many ways to like sort of sync your data. The idea is that we provide people the flexibility to do so, right? So that's sort of like the value prop that we're bringing in. And yeah, this is how the connectors and connections work at Airbyte. And I'm going to go into, I guess, a little more. One thing that we're working on right now that I mentioned earlier is Airbyte. And essentially, it is just like a Python library. And we're basically trying to get users to, I guess, like, especially people that want to use like LangChain and Llama Index, right, to use this to have like more control over how they're leveraging Airbyte tools. It's one thing to go inside Airbyte's UI and like actually build the workflow, right? But it's one thing to programmatically do it, and many people prefer the latter. So that's sort of like our goal throughout this, and it's better for a production environment anyways, and for ML pipelines in the future. So that's sort of like the vision forward, I guess. And yeah, that's it. Thank you.
Thank you so much. And do we have any questions? Around? Yeah, it's right here. One moment, let me pass this back to you. There is a question in the front.
Hello? Yeah. Yes, it was done on the cloud, on the browser. Yep.
Any other questions? Yes, right back here.
Yes.
Awesome, thank you. Thank you so much. There's one right here, yes.
The other question is that you say that you will integrate with Elasticsearch and Neo4j, but majority people using Elasticsearch for semantic searches. Are you replacing that function from Elasticsearch?
Are we replacing?
Semantic search.
No, I don't. So I think like the role of, I mean, maybe like Ben or Teo can answer more to this, but I think the role is essentially just the movement. We're not actually dealing with that part of it. So it's just the movement layer that we're focusing on, like the ETL layer. But yeah, do you want to answer this actually? Okay, I'll give it to you.
So we're focused not on all the beautiful magic that you have Elastic and Neo4j doing that's actually with the AI process. We're feeding those processes the raw data that it needs in order to turn into all of this AI magic. So we're trying to get the data, we're trying to get the raw data from where it accumulates out in the wild into your GraphRAG. So into the big pot of data that you're actually going to use to power all of your AI projects, if that makes sense. But that one of the things I love about Airbyte is we're focused on moving your data real good. Put it plain and simple, to make sure that from point A to point B, your raw data is ready for you to actually use. Because that, believe it or not, that part of the logistics is an immense amount of work by itself.
All right, we have one more up here, and then we'll move on.
Does Airbyte store data as like an intermediate database?
We just pass it along. So that's another advantage for us, is we don't save any data internally. Without getting too far into the weeds, we do keep some things in memory or cache while we're actually running it, so we can actually have an accounting of the data and actually arrive where it needs to. But once that happens, we don't keep a copy of that. That's only in your destination.
All right, thank you so much. Awesome, thank you again. Let's give another round of applause. Thank you so very much. All right, up next we have a special guest, JP Du. He is the founder and CEO of Datastrato. Highly accomplished gentleman here, and he will be chatting with us, I'm sure, about Datastrato.
Yeah.
Okay, I'm going to pass this one to you. There you go.
Thank you.
Yes.
Hello, everyone. So thanks for
everyone to attending today's meetup. I think I'm very excited to share a little bit about the Graphtino, what is Graphtino, what is a catalog and why, and what's next. Here's a little bit about myself. I'm a veteran in the data industry from start my data journey since Hadoop in Hortonworks. I've been in data industry for more than a decade and open source as well, and work on a couple of the open source projects. Before I started my company, Datastrato company, I've been working in different data company and with running hundreds of petabytes of data. So that is a great journey for me. And recently we see AI trend is the AI wave is rising up. So that is exciting. We can see that the data has more value in these trends. Okay, so here's a little bit about data catalog. So what is a data catalog? Actually, the data catalog is it's a metadata repository, tracking all your data assets, including your tables, your data sets, and all your files. And with this kind of data catalog, you can easily to manage your data, discover your data, and governance your data. So we know that from a very long time, we know there's a couple of the data catalog. But actually, there's two kind of data catalog. One is you can do data governance only. That is like a data hub, like open metadata, like Atlan. The other one is not only support for data governance, but also support for data computing. They can work with your engines, like a Trino, Flink, Databricks, whatever. So basically, what's the key difference? The key difference in, I would say in technically saying is a three difference. The first difference is about the metadata synchronization. For governance, if this is only for governance, then that means this is not the real time. You have to copy the metadata from one system to another system, right? This is for synchronization. It's maybe not. It's a final consistent, not a strong consistent. That means the Trino engine or the other query engine cannot consume it directly. The other one is about the logic data, metadata, or physical metadata. That means if it's for governance only, you can just have the schema information, right? You have what a kind of table, column, this kind of stuff. But you don't have to dealing with like a partition index, many physical location info. But actually, for a technical metadata, or you handle talking with your query engines or AI engines, you have to dealing with this kind of details. The third difference is about, just like I said, it's a real time or not. If this metadata info can reflect what your system, the current exactly status, then you can consume by the computer engine in the real time. Otherwise, it can only to dealing with the governance. So this is three differences. So why I would say, open source data catalog matters a lot. So the first reason is the metadata is so important in this kind of data massive of data time, especially when we see them, a lot of multimodal data, no matter it's an image or it's unstructured data or what kind of it. And the other is the data going to the multi-cloud instead of a single cloud, or instead of within a on-prem environment, is actually distributed over different locations. The reason why open source data catalog is important is because there's too many silos from data we're already seeing, no matter from different table formats or from different engines or different cloud or structured and unstructured data. We can see so many silos there. And we believe the proprietary technology doesn't help too much. The only open source, open solution is more helpful. And third reason is data catalog is the only missing piece. If you look at the whole modern open data stack, in the engine part, we can see Spark is OpenStack for batch mode, right? and trainer is kind of ad hoc query, and PyTorch RAID for AI training. But on the layer, we can see different data lake formats such as Iceberg, such as Hoodie, and some new format like Lens for AI training. So, but there's a missing piece in the middle for data catalog. So we have Hive Metastore serving as old one, but it's too old. I mean, it's already 15 years old. So there's definitely not a state of art data catalog now. So there's a missing piece here. So that's why open source data catalog is very important. And another question is why the unified data catalog matters. If we don't have the unified data catalog, then we have to build in the catalog in each different compute engines. That is this picture, left picture shows that we have in cloud environment, the cloud data warehouse, we have some catalog, right? And in the open source world, we have something like Hive Metastore to support some old some engines, and also for other commercial version like Databricks or Snowflake or ClearHouse, they also building their own data catalog. The reason this kind of things is try to building the new silos. So that means when the different engine want to share the same piece of data, they have to be registered again. Maybe data will move where some data movement again. So it's definitely not efficient and not effective. So what do we think the most important architecture, or the architecture make more sense, is the right side. We should have a unified data catalog. Then it can work with different table formats and work with different engines and work with unstructured data to try to glue everything together. So this is our vision is the one data catalog for all engines and formats to simplify everything. So that's why the reason we deliver the GraphRAG Apache project now. It's a next-gen unified data catalog for data and AI. So we just are solving the problem we just are raising out. That is, we have a big picture of your whole data, right? There's no data silo, there are no data pieces. And also we want to try to achieve the single source of truth. When your data silo happens, you need somewhere to gather the information, data repository information together, and we try to be in the new single source of truth. If data warehouse is not single source truth again, then we need some lakehouse federation solution. So definitely metadata is the key part here. And also we want to achieve the data governance in one place. No matter you have on-prem cluster or you have some different cloud IAM system, you need one system to fit the different situation. So next, the data catalog is we think is a core in the new open data architecture. So this here is a little bit about GraphRAG architecture. So basically, we're abstract a different type of data catalog, including the table, the file set, the model, the topic. It covers data warehouse, database, data lakes, and also AI native data and model. So with GraphRAG, so basically you can build in the lakehouse federation that is across the multi-cloud, multi-engines, and multi-formats. From what I'm seeing, a lot of user or customers actually at least facing this situation, at least one situation. Some of the user actually have the multi-cloud deployment. Some are using different engines, streaming, batch, or ad hoc query. And also some company, they're actually using different table formats. Previously maybe Hive tables, and now they more and more using the Iceberg format or Hoodie format. So that would have a problem if without this Unity catalog layer. Okay, so what's next? I mean, that is the overall describe why we need a new generation of data catalog that is, solving the problem. But what's the next? I mean, the data for AI is definitely a very important topic. That is also our meetup, the name of the meetup. So I would like to do a quick survey here. So how many people of you think yourself a data engineer? Can you raise your hand? Okay, 1/3. How many of you think yourself the AI engineer? Can you raise again? The same guys? Anyway, so basically we think the data engineer and AI engineer are kind of two animals. Two kind of animals are different. Because if you look at the AI engineers, they actually, circle around the models, right? All their work is around the model, from, launch the model, experiment, and, registry automation, all that kind of stuff. You find that model is important. But actually, just like previous speaker in Airbyte said, no data is no AI. I totally agree with that. So if we look at the AI engineers, pipelines, all around data, right? From the input data and processing the data set, and we have some models, and we put in some data into embedding into the vectors, and we do the prompt or fine tune. Whatever, I mean, in each stage, we have to dealing with the data together. So if you look at the AI engineers, you will find the taste or behavior is different with data engineer. They actually like, data at hand. They don't like, it's the long data pipeline for ETL, this kind of process, right? And they like the Python, like the data frame, like a model, like using directly pass to talking to the data directly. It doesn't like traditional like a Java stack or other stack. It's totally different. So this brings us a question, right? So the data team and have to work with the AI team, just like I said. The AI models, AI trainings, AI or RAG, they actually bring more and more value here. But how data team can work seamlessly with the AI team? So how to preserve the AI engineers, the conventions, while keeping the data still under manageable. So that's a big problem. So that's why we design, in GraphRAG, we designed the file set. We have considerations, 4 considerations. The first, we have a virtual container to managing the files, directory, the object. So this is a virtual identifier. That means simplify a lot of things. We know AI engineers want something simpler. They don't want to, move the data back and forth and you change their, scripts or their training models to reflect this. A second is we still have the unified governance ability to manage files. We don't want to make, file management very hard to track or very hard to organize. And third one is it's compatible with existing tools, libraries, no matter you are using S3-like or HDFS-like or some other generic file access form patterns. And also all these considerations end up with, we try to keep the convention of AI engineers' behaviors. So here's a little bit more details how we design the file set. Actually, because we are abstracted the whole layer of catalog schema, so we put the file set under a file set schema here. The file set can including name, your storage location, and your type, and also there's some properties that you can apply some TTL management or permission management here to have a more additional metadata information, which is important because sometimes the unstructured data means the data doesn't have metadata, right? But doesn't have a schema. But you have to enrich more metadata info to make this kind of data more easy to managing and more easy to discover. And also for the file set governance, we have audit, we have Airbyte, we have lineage, which is all important in the unstructured data kind of the lifecycle management and the permission management and tracking what is frequency of use in TTL management. If you want to saving more capacity, or if you want to move some unused data into a cold storage, this kind of information is quite important. We have found it. We have in some user of the Graphtino, using this to achieve saving up to 40% of storage cost. And also we have some tools, develop some tools as SDK to access a file set. We have a Java SDK, we have a Python SDK. We also have a fuse, a file set fuse in what that is a work in progress, which is using the standard I/O to read-write file set. And here is our future plans. We definitely just released 0.7 in the community. We are moving fast. We have five major release get released this year, and we have 3 or 4 minor release get released as well. So for next 1 or 2 or 3 major release, we are adding more and more feature to make Airbyte, to make support more kind of blob storage other than the AWS or GCP's blob storage. We also prioritize the fuse support for the file set. Okay, so a recap on what we're talking about the next generation data catalog. So there's a couple of things make sense. First, you need to support computing and governance together, right? And also you have to be open source, just like we discussed, open source matters. The third is a unified data for different engines, data formats is quite important. And also the capability to manage the unstructured data. So if you look at all these open source projects, they end up with Graphtino and unique data catalog, open source versions. And we actually, Apache, after we donating to Apache project, we found through the open governance, the community has a lot of activity on top of that. So we achieve many great milestones to achieve. Like we have 1 million downloads in the first 9 months. Also, we have achieved the good job in the GitHub stars. That is, the trend is very similar to Iceberg in the early stage, but it's 2x faster. And also for community activities, if you look at Unique Catalog and maybe other project, you can see we're also doing good job here. That's all thanks to our active contributor in the community. That is thanks. And that's pretty much from my share today. Lisa only gave me 20 minutes, so I didn't prepare too many contents. So for many details, if you have questions, you can raise your questions, or you can talk to me offline. So here's my LinkedIn, and you know how to find me. And this is our project. You feel free to. Okay.
So I was wondering, a lot of what you're talking about is files in the file system, which sounds very batch-oriented. And there's a lot of people now that are doing streaming data, and you have ClickHouse as a logo. What are you doing in terms of metadata management for streaming?
Yeah. So actually, we have stream schema registry effort. So we work with Kafka, a Pulsar, this kind of stuff, so that the topics can register directly into our metadata system. So if you want to do a join, with one table with some stream table, then it can happen directly. That's a very good question. Thanks.
Any other questions? Right up here.
Yeah.
Can we also create semantic layers with the data catalog?
Yeah, I think semantic layer it's also the potential that we can build across metadata, because once you have a metadata catalog, information, schema information, then the next step you can do is try to, to building a semantic layer, right, with all, the metadata info you have. So that's definitely we can build on top of that. Yeah, we actually, it's a customized. By default, it's maybe directory level, and eventually it can be a file level, object level. Yeah. Thanks.
Any other final thoughts? Right in the back. How is this useful in an agentic AI agent flow?
Agent flow, okay. I think that, we have a blog together with Llama Index maybe 2 months ago. So definitely our position ourselves is a kind of data IO layer for agent. So agent, you want to query or get in some your information, maybe some from unstructured data, maybe some from the structured data, maybe from the vector database. You need a data hub, or you need a hub of the layer that you can access. So we have the blog post with the Llama Index. Definitely through this, the multi-model data is easy to be consumed by the agent or large language model. Thanks.
Any other final questions? All right.
Thank you.
So very much. All right. Thank you. So I want to get this right, so I'm going to read it. But we've just compressed months of learning into the same time it takes to debug a SQL query after a long weekend. You're welcome. Happy Tuesday. Okay, we have one more speaker, but before we get to that, because all of you have made it this far, and that's a feat in and of itself, I have a couple of questions for you, and we'll see how far we can get through them. Just one moment. Okay, we'll get back to that. All right, fun times on a Tuesday. You guys ready? Really quickly, we have a little bit of swag for you, and we're going to ask you a couple questions. This is the first one, so you can get your brains going on it. Closest similarity answer, most similar answer, will win some swag. All right, why did the data engineer break up with the data scientist? There was no connection. That's an awesome answer. Any others? Because they just couldn't map to the same schema. But we do have a winner. Here we are. Thank you. Appreciate you. Yeah. See. Yep. Okay. Next up. Why do data engineers make terrible comedians? And I'm not a data engineer, so, I get to be up here and be an excellent comedian. Yeah. They have too much data to process. Anybody else? Highly analytical. Okay, we got 2 contenders. Because their jokes always get lost in transformation. I don't know. Which way should we go? Crowd, A or B? Who votes for the first answer? Yeah. Okay, second? I think we're going first. It's very democratic. Let's go. All right, last one up. Why did the data engineer bring a ladder to work? Anybody? Yeah. It's ceiling pipes breaking. Okay, maybe right here. He has very big data. Okay. In the back. To what? What about the pipeline? To build the pipeline. So we have broken pipes, pipeline, and big data. To scale the database. I think we're closest with big data. Okay? Yeah. Woo! Yes, thank you all so very much. I think, how are we looking, Miss? Okay, so we're going to take a short break. We have one last speaker, if you guys want to walk around a little bit. And there's more food and drinks in the other room, and we'll be right back on. Thank you so very much. it's just this. Oops. Okay. All right, everybody. We're coming back. You can go ahead and sit your computer down. I'll just do the dancing. Okay. Okay. All right, guys, we're coming on back. I'm so excited to welcome our next speaker as folks funnel in, as we continue to funnel in. Thank you all. Thank you so much. Okay. All right, folks, thank you so much for joining us again. We have one final speaker, saving the best for last. Daniel Dye is coming to us from Roku. He's specializing in query engines, data integration, and security, and his current focus is Spark on Kubernetes and Iceberg. He is a PMC member and committer for Hive and Pig for many years. Welcome, Daniel Dye. Thank you.
Good night, everyone. Are you hungry? I'm very hungry. I just want to finish the talk sooner. All right. So, can you see the screen? All right. All right, so who are we? We are Roku, and we are the #1 streaming OS in the US and Canada. We have 85.5 million streaming households, and over 32 billion hours watched every quarter. So that's about us. And how about the data team? So I'm from the local data platform team. So we are mostly on the GCP. And we built the platform in-house on the Kubernetes. So we have everything running on the Kubernetes: Airflow, Spark, Trino, Flink, Superset, Looker, and Jude. So we just use GCP for the raw machine. We use the VM, but we don't build anything on top of the GCP. So the story is we just migrate AWS to GCP. So I never see actually anyone did that before. Just migrate the whole thing from AWS to GCP, the whole data warehouse into the GCP. So that's the thing. We try to avoid anything high level. We just want to use the machine, raw machine, and the Kubernetes. And that's what we are doing in the last 1 year. So we migrate the whole system from AWS to GCP. But I'm not going to talk about it today. So if you are interested, we can talk about it, but not today. And we are currently building the Spark on Kubernetes platform. That's I'm going to talk about today. And since we only have 20 minutes, so it's probably just an overview. And the other thing we are working on is we are adopting Iceberg, which is in the next few months. And the motivation, we are doing the Spark on Kubernetes. First is cost saving. So we are using Dataproc currently, but GCP actually charges 30% of the license fee. So that's the first thing we can get rid of. And the other thing is we want to be cloud agnostic. As I just mentioned, we have everything running on the Kubernetes, and we don't want the vendor locking, so we just want to move everything away from the data proc. Also, you can still keep the data proc because every cloud vendor still have something similar to data proc, but still you will somehow lock down to their platform because of some advanced feature, their performance. So it makes things a little bit harder to migrate if you just use the data proc. So probably after 2 years, we will migrate again to the AWS just for the cost saving. So we have a good experience to negotiate with the cloud vendor, different cloud vendors, so because we have the ability to move. If we lose this ability, then we probably don't lose this negotiation power. So, and the other thing is for the supportability, because we want to support ourselves. Otherwise, you rely on the GCP folks or AWS folks to support you. It's fine if you have something non-urgent, but if you want to fix this tomorrow, that will not happen. And we also want to get a fine-grained access control. So that's the thing Spark on Kubernetes can give us. And already mentioned that we want to unify all the computing on Kubernetes. Spark is not something special, so we want to move it to Kubernetes. So this is the architecture. That's not something surprising. So we just use Airflow and gateway. So gateway is just one machine, and you can log on to this machine and run the Spark submit command line. And you submit a job to Unicorn. So Unicorn is the resource scheduler, and it will launch the job on the Spark on Kubernetes cluster. So it will launch driver, and the driver in turn launch a lot of executors. And we have the uniform, that's for the remote shuffle, and the dashboard, and also, sorry, this is not uniform, sorry. I just mentioned we want to use the Spark on Kubernetes to solve the security issue, because otherwise in data proc, every cluster we have to configure differently. So for this cluster, this team, they can access this location, and the other team, they have separate access policies. They need to create a separate cluster, which is not flexible. For Spark on Kubernetes, there one thing, you can attach your IAM to the namespace. So you can say, for this namespace, it's running for this team, and it can access those kind of location. And the other namespace, you can access another set of location. It's more flexible than the data proc. And since you can still specify the IAM for every namespace, it's not truly dynamic security policy, right? It's not per job, but it's per namespace. It's better than the data proc approach, although it's not exactly the thing we want to envision in the future. And yeah, so since we use the IAM policy to protect the cluster, one thing to mention is Hive metastore is still our metadata store, and this is not protected. So, so people cannot read some file, cannot write to some location, but they can still access all the table metadata. They can still view all the tables and drop any tables, which is fine because the metadata is not that sensitive compared to the data itself, but eventually we want to fix it. So we probably don't want to spend any time on the Hive metastore. Fix the Hive metastore is not our best interest, but in the future, maybe in the Iceberg catalog, when we move everything to Iceberg, because we have some very nice catalog there. So hopefully we can solve this metadata security issue with the Iceberg. And how people develop Spark on Kubernetes. So Airflow, they have the operator, they have the Spark and the Spark SQL operator, so they can launch the job, and they can also kill the job, which works nicely. And the other thing you can launch the Spark job is via the gateway. So gateway is just give you a shell, and you can log on to this bash shell and launch your Spark submit command line. So this is for people to test the job. So production, they will use Airflow. And several more things to mention about the Spark on Kubernetes. One is the resource isolation. This is especially coming from the young world, because most of the young clusters, they don't have the CPU isolation. But with Spark on Kubernetes, you get the C group isolation. Although you can implement the same thing in Yang, but I don't see a lot of people implement that. So one of the shock when they migrate to Kubernetes is they will throttle your CPU usage, which we never do that in the Yang. But in the Kubernetes, they will throttle your CPU usage. This is especially true when you are using multi-thread library in Python. So they write a Python job, and inside this Python, they will use NumPy, which is multi-thread. But for Spark, we know this is a single thread model. For every task, you're supposed to only use one core. But if this Python library will invoke something which use multi-thread, then you're actually not supposed to use that much. And Yang don't care, but Kubernetes will throttle you. And also GC, we know when JVM is doing the GC, it's multi-thread. But here, we have the CPU throttling, so you probably won't get enough CPU to do the GC. So GC will become slower, and those Python library using multi-thread will become slower. The other thing to mention is the affinity policy, because we don't want to executors run in different zone for a single application, because they will incur a lot of class zone traffic. We don't want it. So we add the affinity rule. So every application, they launch the executors, all the executors will be in the same zone. And next thing to talk about is shuffle. So in Kubernetes, we don't have external shuffle like Yang. Yang have the external shuffle, everybody just use external shuffle. But Spark on Kubernetes, they don't have external shuffle. So what do we do? Where do we put the shuffle data? So one thing you can do is you just put the data in your root disk volume, right? Something similar to your Dataproc cluster. So Dataproc cluster, you have a root volume and you put everything there. You can still do that in Kubernetes. So you just say, I want to put everything in the empty dir. That's your disk, right? You put everything there. However, we find this empty dir is 30% slower than the native disk. For the reason I'm not sure, maybe the overhead for Kubernetes we haven't figured out yet. But we know if you just use the empty dir, you want to use the root volume of your disk, it's 30% slower. So the other choice is we can put on the PVC. So PVC is the volume. It's a remote volume. It can attach to every pod. So in this picture, you can see for every executor, you attach a PVC, right? So you can put your shuffle data there, and the performance is good compared to the empty dir. PVC performance is quite good. So we know we put the shuffle data in the executor itself. So the problem is the executor cannot go away. Even nothing is running on the executor, right? The executor cannot go away because it's holding the shuffle data. So we cannot do the dynamic allocation because of this reason. So in the later version of Spark, they have something called soft dynamic allocation. That's the dynamic allocation with shuffle tracking. That means you can still you still need to keep the executor if the shuffle data is used. But they have some mechanism to figure out if your shuffle data is no longer used. There are some setting for this, and if it's taking enough time and Spark figure out your shuffle data is no longer used, they can still take this executor away. This is a little bit better than no dynamic allocation at all, but it's still not good enough. So we know, so the executor have to keep the shuffle data. What if the executor lost, right? There are a couple of reasons you can lose this executor. One is you use the spot instance. Then GCP or AWS can decide, they can take away your instance. If the surge price increase, right, they can take away your spot instance. And the other thing is the executor can crash. It can run out of memory. It can have some other issues, right? So in those cases, your shuffle data get lost. Then you have to do the state retry, and it will become very slow. And one thing I just want to briefly mention here is in the PVC shuffle, so you put everything in the PVC, and it seems to be there is some mechanism. So Spark, when it reuse this PVC, and it will try to figure out what's left on this PVC volume. So it tried to recover some untracked files lost by the previous executor. However, it doesn't work as expected, so we just never use this. And the other way to keep the shuffle data is we can use the remote shuffle. So we are using Apache Unifor, which is a quite popular shuffle server. And one thing is not so good is it's around 20% slower compared to the normal PVC approach, but it's still fine for many of the cases. So with the remote shuffle, although it's 20% slower, but in trade you get true dynamic allocation. That means you don't have to keep the executor around if there's nothing running on your executor. So this executor can go away and save you some cost. And also you can use the spot instance. So for us, spot instance compared to your 3-year committed price, it's not a lot different, but still it's around 20–30% difference. That's enough to cover the slowness we introduced for the remote shuffle. So yeah, so remote shuffle is something we adopt. And the other thing I want to mention is the PVC performance. So actually we've spent a lot of time to figure out this. And so usually on AWS, on GCP, you will use the PD balanced or PD SSD. That's just a standard remote SSD disk attached to your virtual VM. And what's the performance for those disks? Actually, it's very hard to say because the throughput and IOPS is dependent on the size of your disk, right? So that's something makes things very tricky. They calculate your performance, for example, the throughput using this formula. So that's 140 Mbps for your base, and plus every GB you get 0.28. So you will do the math and figure out how quick your disk is. So if I want to, and if I know in advance your Spark application have to achieve 400 Mbps, then do the calculation. That means we have to use a 1000 GB PVC, right? So no matter you want to use that much or not, so you have to use 1000 G PVC in order to achieve this performance. That's something not cool, but add to this, there's one more problem. Let's see, what if you double the machine size? So now you have more memory, you have more CPU, you basically double the machine size. But in the meantime, originally you can only run one pod in the machine. Now you can run 2 pods. Did that make things similar? No, actually not. Why? In the left hand, we have one machine which running one pod, right? So let's say we have to attach 500 GB PVC to the pod. So if you do the calculation, the bandwidth for this PVC is calculated with 140, that's the base, and 0.28, that's per GB, and multiplied by 600 GB, because your PVC is 500 G, and you have 100 GB boot disk. So the calculation is the total disk volume attached to the VM, so that's 600 GB. So it's calculated 308 Mbps. And on the right side, you have a bigger machine. We have 2 times CPU, 2 times memory. So in theory, you can put 2 pods there, and every pod still needs 500 GB PVC. But if you do the calculation, the bandwidth, total bandwidth for this PVC is 140, that's the base, 0.28 multiplied by 1100. That's 2 PVC plus the boot disk. So the bandwidth for this disk is 448. But now this 448 is shared by 2 pods. So essentially, this will slow down your disk performance compared to one smaller machine with one single pod, right? So that makes things very unpredictable because you don't know whether I get a big machine with more pods or I get a small machine, it's just one pod, right? So in order to fix this, we tried several things. Local disk, they're supposed to get the best performance. It's cheaper, but the problem is you cannot use as PVC. You can use as the root disk, and you use the empty DIR mount into this root disk. That's okay, but as I just said, there's some overhead for there's some overhead for Kubernetes, you see 30% slowdown. So you wasted 30% of performance. And the other way is you can use hyperdisk. Hyperdisk is something you can specify the throughput and IOPS without regard to the size of the disk. So the size of the disk and the throughput and IOPS, they are totally decoupled. So you can say, I want this much big disk, and this is my IOPS, and this is my throughput. So the price-wise, it's fine. So they have the formula. So they have 3 components. You add together, that's your price. And you can see they charge the performance and the size differently. That means if you really have a very small disk, it's not worth it because you still need to pay fixed price for your performance, right? Even if it's a very small disk, you still need to pay that much. So, but if your disk is big, then it's worth it because you still pay the fixed price for the performance, plus your disk size is bigger, but the tax for the performance is the same. So if you do some calculation, if I need a 100 GB and 280 Mbps disk, for the hyper disk, you use this formula 100 GB for the storage. And suppose you have the same ratio of the IOPS, that's 6,000 IOPS. And what you get is $28.6 per month. And if you want to achieve this 280 Mbps, how big this has to be if you want to use the PD balanced? If you use the previous formula, right? So you will calculate, you have to use 500 GB disk to achieve the same 280 Mbps. Although I only need a very small amount of it, I only need 100 GB, not 500 GB. But in order to achieve the same throughput, you have to get a 500 GB PD balanced disk, which calculated as 56.87 per month. So, so hyperdisk actually not expensive. We can just use it, and you also avoid this problem, unpredictable performance if you have bigger machine, small machine. So your channel is totally independent. Whatever throughput you buy, you get it, right? So that's what we eventually settle at. Yeah, so I talk about so much about shuffle and disk performance. So coming back, I just talk briefly about debugging and monitoring tools. So most time you just use history server to debug, and also the Spark UI I forgot to mention. And we built a bunch of dashboard. We track the regular things such as peak memory, and we also track the PVC usage. So we know every executor will attach the PVC, how much you are actually using. So users usually don't have idea, but we have the dashboard, so they can just grab a very big PVC volume and see the dashboard, and they can tune down with actual usage of your PVC. And also the disk throughput and IOPS, we also have the dashboard. Although this is not provided natively by Spark, but we use the C advisor as the container provision. So they have the metrics for the disk write and read. So from that, you can calculate the throughput and IOPS. So we built this dashboard so user can figure out how much IOPS and the throughput their Spark application actually use. And they use this formula and can calculate the performance for the hyperdisk. And they will use exactly what they need for the hyperdisk performance. And besides that, we have the profiler, and we have the resource usage diagram, so people knows for every namespace how much they are using, and we can make sure it's not running out of the resource for the entire cluster. For the cost attribution, so Google actually gave us a nice table. They have the cost attribution, they have the namespace. For this namespace, how much you are using every day, every month. And you can also group by the label. So they can take arbitrary label. So we just label our pods. This pod belongs to this application, and this pod belong to this workflow. So we have the workflow label and application label. So you can get the cost for each individual application, each individual workflow. So it's actually quite flexible. But one thing is the GCP cost attribute, they come late. So it's about 6 hours late. So for some immediate needs, such as performance testing, we just want to run the application, and when the application finish, we just want to know what's the CPU and the memory usage for this application, so we can compare the performance, right? You don't want to wait an additional 6 hours for those data. So Unicorn actually gave us the usage data through the log. So they have the Unicorn log. It will capture every application, their usage when the application finish. So we built the ingestion pipeline. So once the application finish, there's some real-time ingestion Flink job. So it will capture the log and send to the one of the iceberg table. So we know immediately. All right, so that's pretty much it. And the future work, I just mentioned iceberg. It's we want to adopt the iceberg once the Spark on Kubernetes finish. And I just mentioned Hive Metastore. We use the Hive Metastore, but the security is not good. So we cannot protect the metadata. And we just don't want to spend time on the Hive Metastore. One thing is the modern catalog, iceberg catalog, I mean, such as the Graviton and also the Snowflake one, I forget the name, sorry. But they also have the catalog security built in to the catalog. So we try to fix the metadata problem with the catalog. Am I on time? All right, that's it. Any questions?
Why is 30% overhead? Why GCP have 30% overhead on Kubernetes? Why they have 30% overhead? 30% overhead.
30% overhead, right? Yeah, I actually not very sure. You mean the emptier, right? Yeah, I'm not very sure. So that's we try to figure out, but current solution we just work around. We just use PVC because the PVC it's just give us the full performance. I guess there's some of the overhead for the Kubernetes because the application actually invoking the Kubernetes API to access those disks, but 30%, I agree with you, 30% seems to be a lot. And when we're testing, we make sure we are not using the overlay file system, because the overlay file system, it's very slow, we know. So we checked, and it's actually using the ext4 file system. So it's good, but it's just...
Is it a Linux file system, basically?
Yeah, it's a Linux file system.
So if you do object, even slower,
Yeah, overlay is even slower. Overlay, I'm sure it will be slow, and we have good explanation for this. But in this case, I really don't know. But we will figure out later. All right.
So when you're considering different catalog options, other than security, what are you looking out for? Like, there's a bunch of options now. Like there's Polaris.
Yeah. And I guess the connector support. So we have several things. We have Trino, we have StarRocks. There are several things we are using. We need to make sure they have the connection, they have the connectability with the catalog. Yeah, I'm not sure something else. I haven't seriously think about it. But security definitely the first thing, and connectivity maybe the second.
I was just going to answer the other person that Kubernetes overhead on stateful systems can often be terrible. Datadog actually found 100%, and then they eventually tuned it to only get 32% overhead. So, again, a lot of stateful systems have problems with Kubernetes. So it all depends upon the system. And you really need a good Kubernetes engineer to get that overhead down.
So worse than VM?
Yes.
Much worse than VM, so why won't Kubernetes? Do the VM really well?
Ease of deployment.
For the cloud guy.
For the cost, yeah.
Any other questions? Final thoughts? No? Thank you so much. Let's give Daniel a round of applause. Thank you so much. Yay. Wonderful. Okay, that is a wrap on our evening tonight. I could throw up another thank you slide, but I'm not going to. We're findable in the same place that you registered for this event. You'll find a calendar to our event, and you'll find, by way of that, all of the co-hosts' contact information and LinkedIn values. We'd love to stay in connection with you. We want to hear about your feedback. We want to know that if you have something you'd like to share with the community. So tap in, let us know, okay? Thank you so much. Have a wonderful rest of your day. Bye-bye.